Okay, now I'm on. Now the world can hear me. Anything we say can and will be used against us in the court of internet.
Should have a guest anytime from now.
All right. Hopefully he doesn't have a connection issue. Get it?
Hey, it's Australia, and I just came back from like a house where our speed was like 10 megabits up and 1 megabit down.
Wow. Wow. Hi, everybody. Hello, internet. I'm grabbing myself a drink, and I'm going to pour my drink. So. There we go, and now for the nice sound effect of pouring out the drink for everybody. Everybody getting your drinks ready? Because I am. Oh, there's liqueur in this. Okay. Thank you.
Good morning, guys.
Hello?
Good afternoon. Did you
Anybody
hear?
there? Yes.
Hello.
Hey, how's it going today?
Good.
Or, well, I should say, is it tomorrow over there technically? I think so.
It is. Yeah, so yesterday was been and gone here.
All right. Well, we're still in yesterday. So I do apologize if we have any issues from that. So.
Oh, that's okay.
Oh, boy.
Actually, are you able to do two cameras from here? So if I was to flick over to another camera like that. Oh, you can see it. There you go.
Ooh. Is that?
I thought I'd bring a prop, and there's so I'm just looking out of our
Richard.
conference window now, and
Oh my gosh. Which is?
a 70 meter.
Oh, that's the big one. So.
That's a big one.
Well, you know, Richard, we had an engineer here from JPL a couple weeks ago, and they brought a mock-up of Marco with them.
Actually, it was funny. I'm surprised you said that because I was relating to that as well. Because when he was talking about the off-gassing, so from the propulsion system, I could relate to that because we had the problems locking the spacecraft at the time.
Oh man,
we were telling them you've got problems.
That's wild.
Why is the screen flashy?
Because it's got a back. Yeah, it's got a back.
So you
cable.
can hear me okay, can you?
Yeah, we can hear you great over here, and also that is like a fantastic view of that right there. And that's the 70 meter, right?
That's the 70 meter Deep Space Station 43.
Wow.
So, and you've got two others. So at the moment it's tracking Mars.
Thank you.
And you've got 3 spacecraft. We're doing what's called an MSPA, or multiple spacecraft per aperture. Some people call it antenna. And so we're actually tracking Maven, Odyssey, and Mars Reconnaissance Orbiter at the moment.
All right. We'll definitely have to talk about that when we get in it. So, but very, very cool. Thank you so much for coming on today. This is going to be, I'm like really excited about this because I've been to Goldstone.
I mean, me too, in a scary sort of way.
No, I think you're going to do great, Richard. I saw some videos of you talking about DSN down there, and you were fantastic in it. So I have very little doubt that you're going to do great today.
Oh, thank you.
Yeah. I'm just excited because this is like something that people don't talk about, but it's like ridiculously important to operations, and like also it's super cool because I've had the wonderful opportunity to go to Goldstone twice, and it's just amazing to see it all in action out there.
It is. Actually, so if you think of how the stations are set up, Goldstone is very much a sprawl. With Canberra, we're all within probably 1 kilometer or 2 kilometers. So we don't have those huge drives between antennas.
Yeah, that is a bit of a thing out at Goldstone. So there's the visitor center, and then it's like a 15-minute drive to Apollo Valley, and then it's another 10 minutes out to Mars
Yes.
antenna, and
Which is okay for a tourist because you're sitting in the car going, "Oh, isn't this pretty?"
Yeah,
But
yeah,
if
definitely.
you're actually trying to get an antenna repaired, it's a bit of an issue because the poor person over at Goldstone has a 20-minute drive out to the antenna
That can do it a little bit.
and back again, a 40-minute RTLT.
Yeah. Oh man, that's great. I love it. By the way, is it pronounced
That's
Canberra?
just all.
Canberra.
Canberra. So the second A is silent. Canberra.
Canberra. Yeah.
Gotcha.
Actually, it's funny. We're doing some training for the DSN, and we had to spell it phonetically. So
Good way to do it. So I will.
So yes, exactly. It's Canberra.
Canberra. Okay, thank you. I'm probably going to mess that up at some
No,
point.
that's okay.
But you know,
So look, Canberra is one, and so if you think of War of the Worlds, sort of from the radio broadcast, it was coming Canberra. So yeah, it's fine.
All right. How's everybody looking so far in the studio? Good?
We're all
Okay.
good. We're at 8 minutes.
All right. We are at 8 minutes out, so this should be super fun today. We have a lot of people.
So what sort of questions are you going to ask? So give me exactly 8 minutes to prepare myself.
Well, I mean, we definitely want to talk a little bit about, how did the Deep Space Network, how did DSN become a thing? What was it always robotic spacecraft? Kind of setups for things about DSN. I know a lot of it. I know enough about DSN to talk to it, but not a lot of people know a lot about DSN. So it's like an introduce the DSN kind of thing.
Oh, that's good. Yeah.
What's up?
I think Richard was on console when the last signals from Cassini came.
Yeah, actually, I grabbed Lisa, one of our producers in here, was just telling me that you were on console, or you think you were on console when Cassini wrapped up, and I
Yeah. I was in that night. I was actually doing an interview for our local, well, not our local, our national scientific TV show called Catalyst.
Mhm.
And so, so we were watching it and describing it as the three discrete signals disappeared one by one in order. It was, there you go. Oh, I love something I can talk to as well.
Yes, thank you, whoever brought this up. I requested this before the show, which is DSN Now, which is such a fun thing to watch.
When it's working.
Yes.
So,
yeah, I noticed that there was.
we've had a couple of issues with it going down. So over weekends when most people would like to sit there and watch it. So we're hoping those difficulties are sorted.
Yeah, it's really really fun to watch that all in action. So I remember I can't remember which stereo probe it was that we're not talking to anymore. I think it's Stereo B.
Well, it's Stereo B.
Yeah, I remember.
So we're mono at the moment.
I remember it popped up all of a sudden, and Twitter just blitzed about, oh, it's back. But it was actually just like a test program that was being run.
That's right. Look, and we have the same things of the level of support for Chandrayaan-2, the ISRO spacecraft was huge. And you had a huge amount of people in India who were looking at DSN Now, looking for the Vikram lander sort of signals. And of course, every start of support, we'll do a turnaround for ranging. And so everybody thought that suddenly it was talking again. So the Twitter feeds would flare up again as well.
Oh, social media. So.
Oh, yes, you can't hide anything.
Nope, not anymore. So. And then also there's a Twitter account too, if I remember, that kind of shows DSN statuses and things like that.
Yeah, there's a couple. So one's a bot. So look, you talk about the interest, I suppose, in certain spacecraft, and obviously some have more interest than others. And you certainly talk about the Voyagers, and Cassini was brilliant as well. But there's somebody who tweets real time, so the status of the Voyager based on the Voyager status page. of what the spacecraft is doing at the time. So it's a good indication of how busy a spacecraft can be when it's just drifting through interstellar space.
Yeah, I pulled up the Twitter account real quick that I know of. It's DSN_status. And I don't know, it's a bot, and I don't know its exact accuracy.
Yeah, and there's another one. I think it's Voyager 2, NFS Voyager 2, which is really good.
Gotcha.
So sometimes I'll look at that and go, oh, so that's what we're doing.
Yeah, I think I've seen that one too.
Nothing
It's
quite-
like, it's like roll rate control gyro test, something like that. And
Yes,
very
a
accurate.
mag roll, which sort of sounds very food orientated. I think I'll nip down to the shops and buy myself a mag roll. So yeah, it's I find it interesting as well. But people have this impression that the Voyagers are just drifting, and that they're both very, very dynamic spacecraft even now. So doing, correction maneuvers for the high gain antenna just 2 or 3 times an hour. So, and this has been since launch.
Yeah.
So and there's issues. Occasionally there can be issues with that. So I've been drifting off a little bit.
Yeah.
I suppose that's where the DSM comes in, because you're the diagnosing the issue to see whether it's spacecraft based or ground based.
Yeah, I think
I'm trying to feed that back to the project.
obviously we need to get into that during this. So this is the good,
Yes. When things go bad.
this is the stuff you want to know. So when good probes go bad. So what's up? Yeah, we'll cover whatever we can today. So
I don't have a time constraint, so this is a day off for me. So the guys were quite surprised when I walked in the door this morning.
all right. Well,
And the time is perfect, because 9 o'clock here, or 2200 UTC, is the time the Canberra operation team comes in and starts transferring from Madrid.
Okay.
So for the next, or until 5 o'clock local, when we've handed over from Goldstone, and then we'll hand over to Madrid at the end of the day.
nice.
And so for the coming hours, we've got Canberra controlling both the Goldstone and Madrid antennas.
Nice.
Follow the sun, works a treat.
Mm-hmm.
2 minutes.
2 out. All right. And we are at 12.36. Once again, 2 out. Thank you again, Richard, for bringing your lovely prop with you today. So it's gonna be great to show that off. So
Well, I was hoping that we were going to see it move as well, but so unfortunately the support for Mars is just a little bit too long. I think it's probably in a couple of hours it goes back. It would have been pretty cool to actually sit there watching it swing round.
definitely, yeah. Okay, you do your thing. So we're just getting some final adjustments on the cameras here, and okay, sure.
Camera 3's not color balanced.
Camera 3 is not color balanced.
Yeah, I'll have to do that in a minute.
Okay. Well, if it's a window issue, we could fix it in post.
Live.
Yep, we'll do it live. Dada's back there just pulling levers and switches and spinning things. And so that's how technical directing works, actually. Lots of people think it's just pushing buttons and moving a lever back and forth. No, there's real physical activity involved in it. Hurdles, literal hurdles that you sometimes have to go over. So, but yeah, so Richard, just to kind of give you a little bit of a rundown, like before we get started, I don't know, was it Lisa that you talked to that scheduled you for
Yes, it
this
was.
today? So I don't know how much, Lisa, did you tell him that we are live to the world and that we have the ability for our audience to chat with us? So they will ask
That's
questions, and we will bring those questions in live, and we will ask those questions often to our guests because we think it's pretty cool that we can offer the ability for our audience to speak directly to people who do these kinds of things. So, and who better to answer it than the people who actually do it. So, so occasionally we'll throw to some questions from our chat room and kind of toss them your way, and usually they'll appear on screen, but I'll also read them out and
That's
just
cool.
to kind of repeat them with that. So that's really one of our big things that we like to do with it, just sort of interactivity. Also, we're just hanging out. It's like, you know, it's Saturday afternoon, Sunday morning. You know, we're just like having breakfast.
Very
Exactly.
civilized.
Yeah, we're having breakfast or something, just like that. You know, we usually aim for somewhere around 40 minutes. 42 is ideal because, of course, it is. But also it goes as long as it goes as well. So,
That's fine.
so yeah, we'll kind of see what happens today, and there I am to everybody now. We got a big wide one there now, and then there's I guess today's medium shot, which is the whole enchilada. So we'll have to see how that goes.
We're holding for calibration.
Okay, we are holding for calibration, which is to be expected. So, yeah. Are we on YouTube yet? Yes? Okay. Hi, YouTube. Hello. So we are officially public today. And wow. I got the Voyager 1 real-time mission status up on my iPad here, and it's a bunch of superlatives. So it's just amazing. All right, we're still working on it. Still working on it. What's up?
Kangaroo interference.
Kangaroo interference.
Wombats. Wombats, I think, is what.
Oh, wombats. Lisa is just yelling, or you're just saying names of marsupials, and I have no idea what's going on. So
Platypus.
Hit them when you go to the Canberra site.
you have to, you do what?
Don't hit them when you drive there
You don't hit them.
because they go on the road.
What,
The wombats.
the
The
wombats?
wombats. Oh no.
Okay. Are they, how big is I don't know how big a wombat is. How big is it? Holy smokes. That's good size.
Yeah. And solid as.
And what?
Solid as.
What? Oh, solid. Okay, gotcha. I'm sorry. So, yeah. I don't know what any of these things are. So,
We'll take you down to the DSN station.
the
and
DSN Zoo. We could take you to what's it called? Man, this is great. My brain is off to a good start today. Let me tell you. So this is going to be a fun show. We'll see how much I remember later today. We could take you to Goldstone, and we could show you the stuff that lives out there, like Joshua trees,
Yeah.
and creosote bushes. And yeah. Oh, actually, when I was at Goldstone earlier this year, they had burros out there. So donkeys, wild donkeys.
Oh.
So yeah. So that was.
Yeah,
that was-
actually, so I'd say hitting a burrow is probably worse than hitting a wombat.
Yeah,
And
definitely.
they do
I
have
would.
an awful lot of burrows out there.
Yeah, I would not want to hit one of those. Those are big and they're built, so that would not end so well. So.
All right, we're ready.
Okay, okay, I need to stop looking at the chat room because it's cracking me up.
When you're done pug locking, we're ready.
I'm not pug locking. I can actually breathe. So, okay, gosh. You're right. Oh, is it okay to keep this here? Is that all right? Do I need to ditch it? Yeah.
You don't need to ditch it, but you don't use it.
Okay, you got it. Ready?
Watch the tally light.
Which I was about to say, which one am I coming back to? Is it that one right
Tally
there?
light, yeah.
Okay, you got it. Hello, everyone, and welcome to Tomorrow Space Orbit 12.36. You guys know me. I'm Jared. I'm going to be your host today for the show. And this is going to be a very exciting show because we are going to be talking about something that is actually talking to things, and it doesn't get talked about very often. And in order to talk about this, we actually have Richard Stephenson from the Deep Space Network, all the way down from Canberra, Australia. As I learned this morning, I've been mispronouncing that for the last 31 years of my life. So, Richard, kind of, if you could explain to us a little bit what the Deep Space Network is, because a lot of folks probably don't realize that that is something that is extremely, extremely important to the operation of the spacecraft in our solar system.
Well, it is. Essentially, it's the only interface the projects have with their spacecraft. So it means that regardless of where you go, so out of Earth's atmosphere,
please.
you need to
Hold, please.
communicate with it.
Oh, okay.
So
I'm sorry, Richard. We're having to hold real quick. So,
Let's do that again.
okay.
Sorry, I'm still getting wired up. Jared, that was pretty weak. We have 30 seconds to grab people's attention.
What's up?
We have 30 seconds to grab people's attention.
Okay, so
the first 30 seconds is the most important time we've got. We need to get straight into, here's what we're going to fucking talk about today. Sorry, I have to watch my language. Here's what we're going to talk about today. Here's why you care. Here's who we've got. Just
Gotcha.
Boom, boom, boom. My name's Jared. Let's go.
Gotcha.
So within 30 seconds, top 30, start strong, go from there.
You got it.
Yeah, there's a little bit of a
Meandering.
there.
Yeah. No, it's okay.
Meandering if we can.
Yeah, no, it's cool. It's cool. So,
Thank you.
okay, cool. By the way, Richard, do you have like an official title for the Deep Space Network, or?
Yeah, I'm the operations supervisor
Okay.
in Canberra, or one of them.
Okay. All right, cool. We're going to redo that real quick, and let me.
So I take it that wasn't broadcast.
Yeah, that's not going to go, and that start was on me. So.
Okay.
So you're doing great, Richard. So we're gonna let's go ahead and get this. All right, you guys ready? Hello, everyone, and welcome to Tomorrow Space Orbit 12.36. I'm Jared. I'm going to be your host for today's episode, where we will be talking about something that is so important to spaceflight that we wouldn't be able to do it without it. And to talk about it, we have Richard Stephenson, the operations director down at Canberra Deep Space Network. So, yeah, so Richard, can you tell us a little bit about what exactly is the Deep Space Network?
Now, the Deep Space Network is essentially an interface between the project and the spacecraft. So obviously, if you're launching a project, so you want to be able to communicate with your spacecraft. And so yes, the Deep Space Network, or NASA's Deep Space Network, allows that communication channel, I suppose. So now there's 3 complexes around the world, and that's to provide 24/7 coverage. We're around about 120 degrees apart. We've got Canberra, where I am at the moment. We've got Goldstone in California, in between LA and so Vegas, just off a small town called Barstow. And then we've got one just outside of Madrid in Spain as well. They're all very similar. So they're all 70-meter antennas and 34. The DSN only has the 2 types. Each one has 170 meter. And currently 4 beam waveguide antennas as well. They're 34 meters.
Now, has the Deep Space Network always been something since the beginning of NASA, or did it come along as NASA started sending spacecraft into space?
No, look, since they had a closed Earth network as well, STADAN, and so, but they always had a deep space network from the late 60s. The big 70 meter here was commissioned was actually operational in the early 70s. But we also had DSS 42 as well. So yeah, as soon as we started leaving the atmosphere, we knew that there had to be a way of communicating with the spacecraft. And that's why the 3 stations were built.
So how exactly?
I should point out, there was a lot more close Earth stations. Obviously, the closer a spacecraft is to Earth, then the view periods are shorter. So yes, there were essentially little tracking stations all over the world.
Yeah, and once we started going further away from the Earth, that's when it was like, okay, now we need to be able to communicate with these spacecraft for a long period of time.
Correct. Yeah.
So with the Deep Space Network in place, what does the Deep Space Network do? Because it acts like an interface between the spacecraft, but what exactly is that? Is that like talking to the spacecraft, hearing from the spacecraft?
Definitely. So we provide not only telemetry from the spacecraft, which is the obvious one, but also the command link as well. We provide that command. And as far as the project is concerned, they'll just see, hopefully, this seamless transition. As I said, we can offer 24/7 coverage, and so we can hand over from one complex to another. So we can provide a constant command link to the spacecraft, but also Doppler, which essentially is a measurement of velocity for the spacecraft as well. We provide ranging, so along the straight line, we can tell you where that spacecraft is. But also, there's a delta DOR, or delta Doppler and ranging, which gives you that spatial aspect to the range as well. So that's what the service we provide. And we do have a number of other agencies that do have their own networks, but the NASA DSN is by far the larger.
And is it all just talking to spacecraft as well? Can you use the antennae for like radio astronomy, or even radar as well?
Exactly right. Yes, we do. In fact, the two are quite closely linked. We do a fair amount of very long baseline interferometry, and that benefits us because we're looking at quasars, but we use those quasars in the delta DORs as well. So yes, we do. We also have a fair amount of host country radio astronomy as well. And on site here, we will have a resident radio astronomer. And so he'll be looking at it as fast radio waves or as pulsars as well, or as Jupiters. So yes, it's not only spacecraft, it is, I said, VLBI and radio astronomy too.
So it sounds like the DSN has a lot to work with. Are you guys like fully stacked 24/7, 365? Like things are scheduled down to the minute to make that happen?
Definitely. So it's certainly all scheduled. JPL, actually I should point out the hub of the DSN is JPL. So if anybody's been to JPL and seen the darkroom, which they refer to as the center of the universe, so the operations chief sits there with the TSSs, and he's coordinating the network. And then you have us at the stations as well, who are actually doing the tracking. So yeah, it's an interesting sort of web all over the world. So I said with the 3 complexes, the JPL hub is the most important. And we were talking about interfaces with the project. Generally, the project interfaces with JPL, and it talks to the complexes from there. So a project can subscribe to their data, and they can have it delivered in real time from their spacecraft, or they can come in the following morning and find this nice little packaged up bit of data that we received during the night.
And to kind of talk a little bit about the antenna themselves, you said that you have 2 sizes. You have the 34-meter and the 70-meter antenna. Is there a reason why they're that specific size?
Well, the 70-meter was built. Actually, they started off as a 64-meter, and they were actually enlarged, and that was directly because of the Voyager missions as they were going further out into the solar system. We needed that extra size, so they were all expanded, and there were studies into replacing the 70-meter or building additional 70 meters, and that was prohibitive. So during the 90s, they thought of a way of trying to replace it. And first of all, they said, well, to replace the 70-meter, you can sort of array 4 34 meters. And so that was known as the 70-meter replacement plan. But in the end, so they said, well, instead of getting rid of the 70-meter, we'll keep it going. And so at the moment, there is no end life for the 70 meters because you just couldn't afford to replace them. But also the 34 meters have evolved now into beam waveguide antennas. So the design has changed a little bit from the classic Cassegrain where you cram everything into the cone. So to now you have the equipment so in a nice, spacious, conditioned room underground, and it's far easier. But as far as why we have the two, it's not just distance. So obviously we need the 70 meter for the Voyagers, but that's primarily for commanding. It's the uplink that we need. We can support the Voyagers if we array a couple of 34 meters as well. But yeah, so it's not just distance, it's also data rates. When we have a spacecraft around Mars that wants to deliver 3 megabits back down to Earth, the 34 meter does not have the margin, and they'll bring it down on the 70 meter. So yeah, so we have a lot of customers who are fairly close into Earth that still need that 70 meter to deliver the high rate telemetry down.
And Deepod Dolphin in our chat room is asking, are you going to be adding more ground stations in the future? As Deepod Dolphin is noticing that there's a big gap over Asia.
No, no. It's funny because if you start looking at where the DSN's evolving, they're now talking about optical as well. I think the first spacecraft that we have that's capable of optical is Psyche, which is coming up in a few years' time. It's not in its core communication package, it's still classed as science. So, but yeah, look, we might, and then we've got to start asking the question, is Canberra, Madrid, and Goldstone really suitable for optical? So there may be a separation at some point, but at the moment where the complexes are, you've got the infrastructure, you've got the antenna. There doesn't have to be any more because we have the 24/7. What we do need to do, because we have fairly congested periods as well where the projects are fighting for time, we do need further assets. So currently in Madrid, you've got two new beam waveguides being built. So we're slated for another one in Canberra, and so is Goldstone. So yeah, what we're doing is we're increasing the number of assets at these complexes instead of building new complexes.
So 3 sites, they're all very close to being equidistant from each other. Is that a choice?
Yeah, about 120 degrees. So they like to use a magic 120 because it divvies up 360 into 3. Mm-hmm. ESA uses the same one. ESA slips theirs slightly. So if you look at where the ESA stations are, they've got one in Western Australia, in New Norcia. They've got one in Argentina, and they've got one in Europe as well. So they're doing the same thing. ESA only has a 35 meter in each one, so occasionally we'll support ESA spacecraft as well if they're getting a little overloaded with their antenna as well.
Yeah, I was actually going to ask, because it's not necessarily a NASA spacecraft that DSN may be talking to.
No.
Who are some of the
No.
Who are some that you support?
Well, at the moment, so we support any agency that NASA has an agreement with. And the current agencies are JAXA, and we support their Planet C and their Hayabusa 2 operations. We support ISRO. Until recently, we supported the Chandrayaan, which was their Mars orbiter, and Chandrayaan-2, which is their lunar orbiter. And so we supported the landing or the lander, unfortunately, when it was unsuccessful too. But yeah, so the spill, the Israeli spill, a couple of years back, so we supported that. And going forward, I think we've got the Emirates on the books as well in a couple of years for their first spacecraft to Mars. So yes, it's any agency that NASA has an agreement with.
And you have to obviously be operating the Deep Space Network at all times. But Ghostkins in our YouTube channel is asking, have the brush fires that have unfortunately been affecting Australia, have they affected operations? And kind of to talk to that too, here in Southern California, we had a significant earthquake in July. We had a 7.1 that was out just about a couple tens of miles north of where Goldstone was at. So does the Deep Space Network basically brush that off and just keep going?
Not earthquakes. Very hard to brush an earthquake off. So as far as the fires are concerned, so look, Canberra was impacted in the early 2000s, and the fires came very close to the complex, and they were fighting fires on the complex then. Well, one of the reasons why Canberra was picked is, as far as we have no fault lines, we're 100% stable here. Goldstone, and if you've been to Goldstone, they've just had an upgrade as well with all their racks, and they have their new soft boots on the bottom as well, just to prevent damage in an earthquake. It was one of the first times I've known an antenna be stopped during an earthquake. So in the recent ones that you were just describing, so DSS 14, which is a big 70-meter there, nice picture. So it was red and required engineering checkout for that after the last one, but there was no damage to that. Look, I suppose if you look at the antennas you're showing, that they're kind of robust antennas. You look at a radio astronomy antenna, and for a start, it might not have to move like it looks like Arecibo. It's just the focus that changes. We have a 34-meter at Parkes, run by CSIRO as well, but its elevation only goes down to 30 degrees. Again, it's meant to look at celestial objects, not spacecraft. You look at the DSN antenna; they look like battleships. I mean, so the big, robust, heavy, and it takes an awful lot to have an impact on them.
And in our YouTube chat, Gregorius Sudharmo, hopefully I got that right, Gregorius, is asking, how big bandwidth and fast can you push the Deep Space Network to? And are there upgrades planned in relation to the new Artemis and Mars projects? And also, Raj Luthra in our YouTube channel is asking as well about upgrades to communicate with spacecrafts and rovers at faster communication speeds as well. So, like, what can you really crank at? Like, what's the fastest up and down that you can do? And then you're talking optical too. So what are we looking at with that?
Look, I have no idea with opticals. We haven't actually seen the design specs for the optical yet. But you look at, it depends on the bands as well. And if you go through the DSM bands that we use, Sierra band, which is about 2.2 gig. So we use that generally to the moon, a little bit beyond. So there are some agencies that use it beyond. Then we start talking about X-ray band as well. So you starting to talk deep space around about the 8 gig. 8.4. Then you start kicking it up to Ka2, which is 26, 27 gig. And we use that for close Earth spacecraft that need to dump high rates of data. Say looking at the likes of TESS, so who are delivering 400 megabits, so which is kind of cranking it out. So then you've also got the K-band as well, which is a DSN K-band, which is for deep space like SPP or Parker Solar Probe, as it's called now. And so yeah, it's, where do we go from here? People are saying that optical, we really need optical if we're going to bring back the bandwidths we want to from Mars. But at the moment, we seem to be able to deliver the required bandwidths with the existing spacecraft that we have. As I said, TESS with 400 megabits is incredible.
Mm-hmm. Yeah, and I actually would like to go back to that screen that we had while Richard was talking, showing the dishes in real time. This is a thing called DSN Now. And Richard, can you speak to this a little bit for our viewers so they can know what they're looking at?
Yeah, so well, at the moment, this is a snapshot of what the network's doing. You've got the Madrid, Goldstone, and Canberra antenna. Look, I love this as well. So this isn't just for the public. So I'll quite happily have a look, and if I'm at home, just see, which is a bit sad, to see what we're supporting. And it shows a 70-meter and the three beam waveguides in each. And obviously the waveform coming down is what's being received. The waveform going up is what's being transmitted. You can see whether it's modulated or not. So there is a modulated wave on it. So you can see if it's just carrier or whether we actually are receiving telemetry. And in this case, they all are. It shows the 70-meter as well in Canberra. It's actually doing 3 spacecraft. And we're actually, you're talking about software developments and evolution of the DSN. It's been identified long ago that Mars was going to be the contention, where we're just going to have so many spacecraft around Mars, and so essentially not enough assets to support it. So a lot of the software developments and the systems at the moment is to expand that capability with the Mars spacecraft to add more. The beauty of Mars is that we can point directly into the middle of Mars, and the beam width of all the antennas incorporates not only the planet, but of a swathe of space on either side. So we don't have any spacecraft outside of that beam, even the big elliptical orbiters like MAVEN. And yeah, I've lost my chain of thought there. With the 70 meter, and I'm actually just looking out the window at the 70 meter now. I might be able to just bring that up.
Yeah, I was going to say.
Actually set up a camera.
Go for it. You brought a prop today. There's your prop.
I talk to props. So this is a current view of the 70 meter. So we're tracking the 3 spacecraft, and as I said, so we point directly at Mars, and there's a number of spacecraft that we can track around it. There is one limitation, and that is we can only uplink to one at a time. So we're talking about high bit rates, and so what's required by the project. So the big one around Mars at the moment is MRO. That requires lots of bandwidth. And they'll increase. I should also say that the spacecraft have variable bit rates, so they can change it. So a spacecraft is uploaded with a schedule, so it knows what antenna it's communicating with. So it knows that if a 34 meter is supporting, then it can drop that bit rate. But it knows that when it's over a 70 meter, then it can increase that bit rate proportionally. So there's a little bit of leeway there. So for instance, MRO on the 70 meter here, so it could be bringing down a high rate. We might not have an uplink available for it, but we can provide that uplink from a 34 meter. So it doesn't all have to be on the same antenna. We can bring telemetry down from one and provide a command capability through another.
And that is an incredible amount of efficiency being built into a system. That is just fantastic.
Well, it is actually. So you're talking about efficiency, and you're looking at our days, and we plan our days and how many spacecraft. We fluctuate a little bit, but generally it's the high 20s. So for my day shift, and this isn't in a 24-hour period. So for my day shift, when Canberra took control of the network at 9 o'clock this morning, and so we relinquished to Madrid at 5 and finish up at 6. We'll have 30 mid-20s, 30 supports during that period, and Madrid and Goldstone will have something similar. So we currently have the mid-30s spacecraft on the books. So it's always a very busy schedule, and you can see when you look at the schedule how difficult it is for projects to find time. Obviously, if a project is desperate and they declare a spacecraft emergency, it's the same as maritime law, where all the other projects have to help out and so give up some time. But yeah, other than that, so the schedule, if you're planning, for instance, an event or a launch in 2 or 3 years' time, that has to go into the schedule to see whether the DSN is capable of supporting. But also, so with the other routine spacecraft, you've got the Voyagers that are supported almost on a daily basis. So they have to find time as well. So yeah, when I talk about building new assets, that's really to not only allow more spacecraft, but also allow the existing spacecraft to be supported too.
And you talked about, coming in and how many you do a day. What is your day-to-day like? Because I mean, the Deep Space Network is not
diverse.
Yeah, I would imagine. It's like we said at the beginning of the show. It's not exactly something that a lot of people know about. I'm sure people can get a really easy day by day as to what it's like for somebody going into Johnson Space Center to be a flight controller for the space station. But what the heck is it like being day by day doing operations at the Deep Space Network?
Well, I said diverse. The beauty of the job, and I was recruited from the UK just straight out of college in 1988. And so I said, who wants to work for NASA in Australia? And I came over here for the Voyager Neptune encounter just prior. So essentially there was a lead-in for training. And since then, so I've been involved with every NASA spacecraft in the last 32 years. So the Voyagers are the only ones now that are still going from when I started. But yeah, so the day when you walk in, it's funny that after 32 years, you're still supporting the same spacecraft. You know, you see Voyager 1 and Voyager 2 like an old friend. But you also get the new projects coming in all the time. As far as my day, I'll walk in, and so I have a team of controllers, and I'm also a controller, so I can jump into the seats. In fact, that's what I love about the job, that I can still get my hands dirty. And it could be, so, you know, 1 minute you're doing, you know, you a Voyager, then you could be going on to a test, then you'd be going into a Parker. You know, you could be having a few issues with Maven around Mars, and that's what keeps it really interesting. It's just continuously cycling through. And just when things start to get a little mundane, so a new project comes along. And so you'll go, oh my gosh, surely they're not going to try this. Now I can still remember where the Pathfinders went and landed on Mars with the airbags, and we were all going, oh, what do you reckon the chance of that working is? But yeah, brilliantly successful. And we've been, after a bad run of Mars, so in the late 90s, so it's been brilliant. So as far as the success rate with our Mars missions since then.
And what's it take to become a controller at the Deep Space Network?
Well, it's funny because, as you said, you just can't go out there and say, I think I'll recruit another controller. The background of all the controllers, it used to be, it was very much RF. So my background is RF and radio and radar, and that's what I did at college. But we also have the digit side as well, and software. And as the DSN has evolved, so has the role as well. Obviously, the system administrator role is far more important. But we identified the fact that, you know, we'd recruited RF people and we'd recruited digit people, and each offered unique skills. But we needed to get the RF people up on the digits and the digits up on the RF. So around about 10 years ago, we actually had a certification program, which was the first time that essentially we had a NASA DSN controller certification program. So yeah, we've tried to do that benchmark. So regardless of where your background is, there's a common knowledge in the RF and the digit side.
And working for the Deep Space Network for over 3 decades, I bet there has to have been some...
Oh, sounds so long when you say it that way.
Sorry, I'm so sorry. I bet there has to have been a ton of interesting things that you have been witness to throughout your time there. And Loopy in our chat room is actually asking, you know, do you have any interesting stories you could share? Any crazy hijinks, close calls, silly technical problems? Like, what's the wildest and funniest stuff that's happened to you?
Look, but there is so many. I have some people on the team, and they'll say, "Oh, do you remember when we did this and we saw this with that spacecraft?" I'm going, "No, not really." So some people have far better memory than me. I just see, "Oh, that was an interesting day. I'll move on to the next." But you know, you talk about spacecraft, and so look, I love the story of in the early days. I think it was the late 90s. ESA had a cluster. Their first cluster spacecraft that were going to be launched. And it was the first time ESA had come over here to support one of those spacecraft. And they brought their own ground systems with them as well. And I can still remember, so you look at the DSN, it's all battleship gray. You walk into the front end areas and all the racks are battleship gray. It seems that it only came in one tone of paint. And their ground systems arrived and they were cream, with Mercedes-Benz all over the top. And I thought, oh, wow, I never thought I'd ever have rack envy. And so the first cluster, we also had an ESA engineer out here, a gentleman called Peter. And he was going to be there for the launch and an early orbit phase as well. And I can still remember standing in the operations room, so watching this launch. And obviously, if anybody knows the first cluster, it was unsuccessful and ended up falling into the swamps of French Guiana. But when we saw it explode, the first thing, so he said, was Scheissen. And he goes, well, I suppose I'm going home. And probably within 5 minutes of that, one of our controllers had strung up a big foresail all over the Mercedes racks. I was sort of hoping they were going to leave them, but so they never did. But yeah, look, one thing so you realize in this industry is nothing is 100%. You know, so whether we've had spacecraft that, and sometimes there can be silly errors. I can remember the Phobos missions that we supported. So, you know, so, and it was all down to a controller switching off the batteries and a solar panel at the same time. So, or heaters being switched off and so spacecraft essentially freezing. I mean, there's so many variables that you have in space. So, and there's so many errors that you can make, and some of them just aren't recoverable. You can't just walk up there and press a reset button. But also you got the same issues here on Earth, you know, so the antennas, although I said they're big and robust, you know, the specifications required to track a spacecraft are absolutely minute. They're mind-boggling, you know, so when you start looking at the beam width, so I keep on looking at the 70 meter out my window, you look at the beam width of the 70 meter, I'll give you a picture just because I can.
There it is.
So if you look at the beam width of the 70 meter is, you know, so with X-band, it's 32 millidegrees. You know, so with S-band, it's 118. And that's for the three, so you half that, and which means that's your error, and then you're dropping the spacecraft by 3 dB, which is enough to kill telemetry if you don't have those margins. So there's always things. The subreflector on 43 we had issues with a little while ago. So, and it just took one tiny component, and so it was wiping out one spacecraft after another. You're talking about the earthquakes in Madrid as well. So look, there's so many good stories, and I saw one of my favorites is Cassini. You know, so as we were talking about before, you know, I was there at the end as well, and it was actually a really sad day. It was a sad day because I think I'd actually stamped this human type personality onto it, because spacecraft do have personalities. So whatever people try and tell you otherwise, and it's a bit like a person. So when you talk to them, you know, so you pick up their mannerisms, their characteristics, and you form an impression. It's the same with spacecraft. Some of them are unreliable. Some of them are always late, just like people. Some of them can go for a bit of a wobble. They can, you know, go a little unstable occasionally, and we have to adapt for that. You know, so I think you had a gentleman talking about the Marcos from JPL, and look, the Marcos were a brilliant mission. So as far as cost effective and essentially success, I mean, they brought the InSight data down flawlessly. But when he was talking about the loss of propellant, so we were seeing that on the ground. You know, we're the ones that are saying to project, look, you know, we're seeing oscillations here. So we're seeing fluctuations. It looks as if your spacecraft is rolling. And so it's a DSN, they'll see telemetry, but without any telemetry, they can't interpret. So what we have to do is say, well, this is what we see on the ground. You know, we are seeing oscillations. We are seeing variations every minute and a half as your spacecraft is rolling. And that's, you know, you were talking about spacecraft, distant ones as well, and the Voyagers. And both Voyagers at the moment, although they're in interstellar space, so them drifting on, they're really dynamic spacecraft. So 2 or 3 times so an hour, they actually have to correct the pointing on the high gain antenna. It's got a 12-foot antenna that has to be orientated to Earth. It has a sun sensor, which so obviously uses our sun to sense, which corrects the yaw and pitch. But then you've also got so the star scanner as well that controls roll. And I always thought that once the Voyager was going to disappear, it was going to be through power. A little RTG, yes, it's half-life, and the thermocouple's degrading as well. But for the first time, we were having issues with pointing from Voyager 1. And we were seeing those on the downlink as well. They were slowly dipping, and we were having problems locking. So from 22 billion kilometers, Project was able to send corrections to the sun sensor and biases. But it made me realize that it's not just power. There are so many things that can happen to all spacecraft that can be showstoppers. And you're talking about the purpose of the DSN. Yes, we have an antenna on Earth, but a spacecraft has an antenna as well that it has to orientate to Earth. And if the two aren't pointing at each other, then there's no mission. So some spacecraft will have low gain antennas, which they can use to, if there's an error, to flick to, allow us to get commands in and hopefully correct an issue. But with the Voyagers, they're so far out, so they have a high gain antenna and a high gain antenna. So if it's not pointing to Earth, then I said the mission ends. So there's always things going wrong. And that's why we're here. You know, those spacecraft that need very little interaction. We can configure it and sort of support it, finish up, and then we have the ones that are very much manual stick control. And they're actually the fun ones. You know, you're talking about lunar orbiters. We've got Chandrayaan at the moment, the ISRO spacecraft. And it's very much manual as it comes out of occultation around the moon. So we manually sort of enable drive to actually capture the spacecraft. So send a command to it. We see the spacecraft go two-way because it's so coherency is what we're looking for, where essentially the spacecraft reference is our clock. Really good for Doppler. We can tell exactly the velocity of the spacecraft. And so, yeah, and then we get telemetry from it. So every day is interesting. And it's not just all about experiences, because every spacecraft is different. And as I said, there's personalities. You have your favorites and not so favorites. And that comes down to the characteristics of the spacecraft.
And do you have a favorite spacecraft? Or is that sort of like asking what's your favorite child?
No, I'll be quite happy to throw a number of them under the bus, but I won't tell you which ones. That is, as I say, it all comes, look, I have probably sentimental sort of attachment to both Voyagers. And as I said, that's because they've lasted my entire career. And if they can just last another 5 or 6 years and see, we'll retire together. So, and then I'd hate to think I was a 2 spacecraft controller. So lasted the entire period. Projects I really like at the moment, the MMS, the Magnospheric Multiscale Spacecraft, and that's just because of the scope. You know, so they're looking for the magnetic connect between the Sun and Earth. And they're flying in flotilla with a degree of accuracy is just mind-boggling. And they'll zoom in around Earth and close up, and they'll go into a data collection mode as it comes back out. Dumps data. It was actually an interesting one because when MMS came along, it was actually a bit of a pain spacecraft to support. So there's 4 of them, and they have to be tracked in sequence. So 1, 2, 3, 4. And you're talking about scheduling, so being tight. To actually incorporate the MMS supports, our countdown time had to be reduced between them to down. Instead of normally 45 minutes, 10 minutes. So we went from one spacecraft to another with only a 10-minute gap. But they, as far as the mission, brilliant. It did offer a couple of challenges tracking, but you know, so that's become the norm now. But even Parker, the Solar Probe, that's another amazing one. And you know, so it's a support that has so many stages. You know, you get where it's about to enter, essentially not far from the Sun's atmosphere, where we have problems talking to it on a really low rate, to as it comes out again, so free of the Sun's influence, and it can downlink, you know the high rate K-band data, and it's flying out as far as almost Venus. In fact, they're actually about to go through a Venus flyby. So look, there's so many really interesting ones. You have ones that you like a little less, but that's purely because they're difficult to support. I would have thought Cassini was, as I said, a lovely one, but it was a pain, you know. So this was a spacecraft not only whizzing around Saturn, but it was doing the moons, one moon after the other. And they had these experiments called bistatic radar, where essentially they use the transmitters on Cassini to bounce off Titan, and we'll receive those bounce signals at Earth. And the preamble for the support was like 3 hours, where we were just following one sequence after another. There was hundreds of steps to calibrate our downlink systems. So yeah, that was a pain, but I still have fond memories of Cassini as well.
And with the Voyager spacecraft, I mean, they're 42 years old. Voyager 1 is 22 billion kilometers away from us. How do you like work with something that's that far away? I mean, the transmitter on Voyager, I think it's like 20 watts, I think is how much power it puts out. It's ridiculously tiny. And then also, like, do you have to use support equipment from 42 years ago to talk to it?
Yes, in a way. So even they've had to. We now have an industry standard. So actually, I should point out that any mission now that uses essentially a CCSDS format, which is an industry standard for communicating to the spacecraft. So it means that we can track any agency spacecraft as long as they're using that international standard. Voyager's had to adapt to that a little bit. So with the commanding, for instance, they've had to go in or transfer into those types of blocks. But no, look, as people keep on thinking, because we have a spacecraft 22 billion kilometers away, it must be the weakest spacecraft we support. And it's not, so not by a long shot. So if you start, and it all comes down to the mission purpose. Obviously, Voyager, huge high gain antenna to deliver data down to Earth. A 20 watt transmitter or 22 watt transmitter. So and we're still able to get 160 bits down with plenty of margin on the 70 meters. So Voyager 1 still has a working 8-track tape recorder as well. And so every few months it will do a dump of that data. So, and essentially, normally it's always covered on Goldstone. And it's a 1400 bits down, and they need the 70 meter and all 3 beam waveguides arraying for that one as well. So, yeah, that in itself is kind of incredible that we can get 1.4K from 22 billion kilometers away. But so it depends on the purpose of the spacecraft. Now we've got MAVEN, for instance, around Mars, and a previous spacecraft MESSENGER, where the primary goal of the project is to collect science data. So while it's orientating its high gain antenna to the planet, it's using a low gain antenna from the back. So, and the signal that it's being received is far lower than the Voyager signal that we receive normally. And the bit rate is lower as well. You know, we can be receiving 11 bits per second. And all they require is a spacecraft help. So within that 11 bits, it's just saying either yes, I'm happy, or no, I need a little bit of attention. Just like New Horizons did, so on its 9-year journey out to Pluto. So it will go into hibernation, so for the long periods to conserve power. And every now and again, it would send a simple tone down, one of 4 tones. You had obviously a happy tone, a sad tone, and indeterminate tones in between. So that was really low as well because it was using its low gain antenna. So it's a strange one. You think the further out it is, obviously needs a bigger antenna, but that's not necessarily true. So it really depends on the mission and their design.
And even though Cassini was a little bit of a pain, if you will, for the Deep Space Network, Mini-Stowage...
In the best possible way, I should point out to the Cassini folks.
Oh yeah, definitely. It's a great problem to have. Mini-Stowage is asking, what was it like to see the loss of the Cassini signal in real time? Because it was a nearly 20-year mission wrapping up.
Yeah,
you got to watch that happen.
I suppose bittersweet would be the best way to describe it. So you had obviously you had the sense of loss, and it was literally a sense of loss. Actually, you only saw the 2. We were lucky, so we'd actually set it up so you saw all 3 frequencies. And I was doing an interview with Catalyst at the time, and I was predicting how the signals were going to disappear. I was saying, well, based on the beam width of the antenna, the first one to disappear would be K-band. And so the next one, because it's such a tight beam, and then the next one that would disappear was X-band, because it's a little broader. And then the last one is a big, robust Sierra band. And so as I was seeing one after the other disappear, each one was a sense of loss. But then after they all disappeared, it was a case of what a brilliantly successful mission that was. So suddenly it was, wow, what an accomplishment these guys have made. And so yeah, as I said, bittersweet. It brought down some amazing science. It was, there we go. So we got X band and S. There was also a K band as well, which was coming down on a 34 meter. 43, strangely enough, doesn't have a DSN K band frequency band. So yeah, so 43 is the, oh, there we go. It's funny the thing to think of afterwards, because after I'd done the interview, I'm thinking, oh, did I get the order right? I had so many self-doubts of getting the order right, of which ones. And it was only when I forced myself to watch it again that I did get it right. But yeah, I was a little paranoid there for a while that it had been broadcast in error. But yeah, so Cassini was look, that was a fun mission. Actually, I should point out, when you asked about favorite missions, probably Hayabusa. So if you're ever going to launch a Swiss Army knives of spacecraft, ask the Japanese. So I mean, that's just, we have our own of Asteroid Chaser with the Cyrix going to Bennu, but the Hayabusa around Ragu, and it's just on its way back now, and its little sample of the asteroid is going to be dropped in South Australia. But that was, we always get the briefings. So before any activity comes, we put everything into levels. Level 1 is the most critical, and it's normally a launch or a landing or an orbit insertion. And then you have level 2, which is pretty darn close to a 1. Level 3 is heightened awareness. And when we get a level 3, they have to provide a briefing of what the spacecraft is doing. And Hayabusa, it was just like, you look at the briefing going, seriously, they're doing this? Whether it's throwing ballistic projectiles at the asteroid, throwing little rovers at it, so throwing out markers as it's orbiting this thing. As far as brilliance, the Hayabusa mission, I think would be right up there.
Well, yeah, I remember seeing a lot of those images and things from it too, and they just, Swiss Army knife really is a good way to describe just how much they packed into
Have a blade for everything.
Yeah, exactly. Even a bottle opener to crack open some samples from the surface as well. So when there is like a major problem with a spacecraft, how does the Deep Space Network handle that?
Well, so first of all, we have to categorize it. I was talking about the issue with Voyager and the project. They're looking at data coming down, and if we can't deliver data, we have to give them a reason why. And so we'll say, look, we're seeing that the spacecraft is low. For instance, the signal we're seeing from the spacecraft is low. We'll go through troubleshooting on the ground to make sure that there's nothing wrong with the antenna pointing, the low noise amplifiers, the receiver systems. We have redundancy for a number of things, not all. If we can throw another asset onto it, another antenna, just to verify that there is an issue. So project don't see telemetry, and we're trying our hardest to deliver it. So whether it means moving up a size of antenna, going to the 70 meter, is one thing. We're also looking at the profile from the spacecraft as well. Are we seeing it modulated? Has the spacecraft gone into safing? So every spacecraft has a safing mode or an emergency mode, where if something goes wrong, for instance, there's a clash between the CPUs or whether the star scanners got out of alignment, it goes into a safing mode. The safing mode normally means that it'll kind of reset, it'll go to a low gain antenna, it'll go to a low bit rate as well. So if we see that break from a high rate to suddenly we go low rate, then we start saying we need to reconfigure for that possible spacecraft safing, and we'll inform project as well. So yeah, I think for the DSN, a lot of the time it's a case of, okay, what are we seeing? The project can't. what can we interpret and tell project that, to the possible issues. Now, we knew from the Voyager project thought that they were hitting link margin. They thought the Voyager 1 was getting too far out. And what we were seeing didn't make sense then, because it wasn't just a spacecraft decaying. We were seeing a spacecraft that was oscillating. So sometimes it was good, sometimes it was bad. And we were able to feed that back to the project as well and said, well, we don't believe it's link margin. What we think is there's some sort of orientation of the high gain antenna. Because we're actually seeing it wasn't just a sinusoidal wave, it was an abrupt change. So we'd see the cycle with a slight kick at the bottom. And that was obviously the little thrusters on board. So with the sun sensor just moving off just a little bit, detecting that it was off point and then just kicking in again. And that's when we saw the signal improve, and it would drift off. So a lot of it is characterizing what we're seeing and informing the project.
And what's the future of the Deep Space Network looking like? Because we have a lot of
Rosie.
there's a lot of folks in our chat room that are asking that. Headcrab on YouTube is asking, with more and more missions and rovers, is there a limit to what you can do? Stephen Porter.
Look, it's incredible. Actually, so there was an earlier question about human space flight as well. Strangely enough, we haven't heard a huge amount of how the DSN will support it, although we have been told it will be supported. Not only the lunar missions, but also the Mars missions. We are going through software upgrades as well, and our new data delivery system has now been modified to include essentially voice communications. It's a self-proclaimed we'll declare ourselves astronaut ready because we can now do all aspects of support. So as I say, we can deliver telemetry and voice. We're still not sure what the demands of the DSN are going to be when Artemis sort of goes up. We're hearing conflicting sort of reports of, they may not want support every day to, yes, it's going to be fairly intensive. And until that solidifies, I think it's very hard to plan for. But, when I first started, we were actually supporting shuttle before the TDRS network went up. So in my career, I have a little bit of experience with supporting human spaceflight. And I can remember in those days, it was incredibly arduous because there was a level of competency required that we've never had to deal with before. And I said, so if that comes in for the new human spaceflight, it's going to make things really interesting for the DSN.
And also, John Benstead in YouTube is asking, will the Deep Space Network support commercial spacecraft that venture beyond cislunar space? So is there any potential private partnerships that are going to happen?
Well, I suppose SpaceX would probably be although SpaceX is trying to find their own network as well. I suppose we have to remember the DSN is not the only game in town. The DSN is by far the largest. So we also have the ESA network as well. We have a number of commercial players coming into the scene too, who are looking at supporting the SpaceXs, and the more commercial aspects of space communications. As far as NASA, look, if a commercial entity went to NASA and said, this is what we're proposing, I'm sure that it would certainly be considered. I said we are doing ISRO. We did do the Israelis at really short notice as well. And that was a semi-commercial. That was, I think, a privately funded spacecraft. So yeah, it's certainly on the books. But ultimately, the DSN has to support NASA spacecraft. And so as soon as we're taking on commercial customers, that gives less time to our core business, which is NASA spacecraft.
All right. So basically, if you want to support your spacecraft, kind of build your own, or give NASA a little reason for doing that with you there.
That's right. So there are different ones. I mean, there's a number of networks for close Earth. You've got the USNO and the Swedish Space Corporation as well. I think the Chinese are building their own subnetwork too. The Indians have a deep space network, but it's really just limited to the skies over India. And that's the same with JAXA. And that's probably why we support a lot of the other agencies as well. Not everybody wants to have to build antennas all over the world. You know, they'll build one in their home country, and they'll ask another agency to support their spacecraft during critical supports, knowing that for the majority of it, they'll be able to support through their own antennas.
And to kind of wrap it up here from our YouTube chat, we have a question from R1, which is something that everybody always, everybody always asks them this, which is that if you had all the funding you wanted, so since you guys the Deep Space Network is supported by NASA, if you had all the funding you wanted, what would you do with the current system?
Boy, more antennas. So we had a group of senators out here, and he said, so, and it was a similar question. So what could we do for you? And I said, more assets. So when you start having projects fighting over time, arguing over who has priority, so then maybe you don't have enough assets. And so I think that'd be the biggest thing. I'd have the 34 meters are great antennas, a little jelly mold antennas, a couple of years construction. We can array. I didn't really cover that, but we can array our antennas so that it takes 34 meters sort of for the equivalent 70 on the downlinks. But yes, the more antennas, the better. I think so. We have the infrastructure in place. We have the control room. All we need is the physical hardware in the fields.
Yeah. Well, it's so cool to hear about the Deep Space Network, the literal bandwidth of the solar system, talking all around and getting that to everybody. And maybe one day we can do Tomorrow from Mars, and we'll have to use the Deep Space Network.
Actually, just on a parting note, so I was listening to an interview with somebody who put their name down for the Mars, Humans to Mars, and they were talking about their journey to Mars. And they were saying, but that's okay. Communications is fine. We can communicate, and we have Skype. And I can remember my first thought was it would be a little stilted in conversation. So I think Mars at its closest is 6-7 minutes round trip light time. Furthest is 44 minutes. So if you're expecting this chat to Mars. So with a 44 minutes of cause and effect, so to get a response, I think it'd be a very long conversation.
All right. Well, I guess we're going to have to bring someone along to chat with us in order to do that. And, we have a ton of questions that we didn't even get to with you, Richard. So we're going to go ahead and do those in our after show today to talk with that.
Yeah.
And one of the ways that you can see that is if you become a citizen of tomorrow. And we always want to thank our citizens of tomorrow as well, because we can't do this show without you. We can't do the news without you. We can't do letting off steam without you. You're the ones who help make this happen. And if you would like to become a citizen of tomorrow, you can head on over to youtube.com/TMRO/join. And you get to see things like what we're about to do after the show with Richard, which is basically everybody who's asked a question so far, we'll try and grab all those questions and throw them at Richard and get you that opportunity to talk to somebody who's actually doing real stuff, which is so cool. I'm so glad we get to do that. And our ultimate goal is to get people excited about space, and our citizens help us do that, and you get to do some cool stuff on the side with that. So that wraps up Orbit 12.36 for us here today. So until the next one, keep exploring. Okay, then. I guess our 34 meter didn't pick up the audio from the end there, so I have to go back and redo that. That's all right. No, we're not going to redo that. So,
Sorry, I'll do this on camera.
okay.
I know this is a break. I know this is a break from normal, but if you have a little bit more time and don't mind, I can't even begin to describe to you how many questions have come in and I'd love to just like go through and rapid fire these things if we can.
Yeah.
Because like,
Oh my gosh.
you have got our entire community super interested in this, and I'd love to give them a chance to like go through all of this.
Yeah. We have 17 questions currently sitting there right now.
Oh, I thought you said those thousands.
And by the way,
I'm not
also,
feeling too bad.
Jamie just can't count to 17.
That's correct. So only to 5. Wait, 1, 2, 3.
Well, Australians use a different
Five.
numerical system.
Oh, okay. So that's how it goes.
Upside
All right. By the way, just want to say, Lisa, welcome back to the
Hi.
States here.
Hello, Lisa.
Finally.
Hi,
So
Richard.
welcome back. Also, we're sorry. So let's go ahead. Let's get those questions started, shall we? There are so many that they fill up the entire screen, so I do not know what is at the top at the moment.
Is that a good sign or not?
That is a good sign. Okay, here's one. Stephen Porter on YouTube. Would a deep space network on the moon be a better place as it doesn't turn like the Earth? Also, would this benefit from less atmospheric problems on Earth? And I'm not sure if the atmosphere does affect DSN or not.
Yeah, it does. Well, the
the
rain
rain.
certainly does.
Okay.
Rain?
We've got.
Right.
Oh yeah. So you talk about the Achilles heel sort of space communications. It's the higher up in frequency you go, the more attenuation you get from the weather. So S-band is really robust. So we have very little sort of issues there. But when you start talking about the X-ray band and the 8 gig, then you start getting degradation. Even light rain can knock you down a little bit. Torrential rain can wipe you out. It's a little bit like when you sit down watching your satellite TV.
Mm-hmm.
And so it's torrential rain, so when the signal goes all fuzzy. It's exactly the same with the DSN. When you start talking about K-band, you start going up into K-band, which is the 27 or the 32 gig. You can actually see the signal vary as clouds pass over. So it's that sensitive. And I suppose as you start talking about optical in the future, then that's obviously more critical again, so that you have somewhere with really nice weather. So could it be on the moon? I think so. The logistics of actually building an antenna there would be sort of really difficult. And also providing that communications back to Earth, so as well. But yeah, at JPL there's a subgroup looking at space relay as an option as well, where essentially you have a spacecraft around another planet, and they're communicating to a series of spacecraft and essentially rock hopping all the way back to Earth to increase data rates. So look, there's so many things on the books that are being explored. I'm not sure about the moon, because although the moon doesn't rotate, it does around us. So it doesn't, even if you're on the far side of the moon, you don't have unlimited access to the sky. You're still going around with essentially a pie slice.
Mm-hmm.
So it wouldn't really offer a huge amount of benefits as far as coverage.
Mm-hmm. Yeah, and Air Icarus on YouTube is kind of speaking to those ideas, because I know that there was one in the late aughts called Mars Telecommunication Orbiter, which was basically just going to be something that would do literally like a relay in orbit around Mars with some science instruments.
Well, actually, Mars, we were talking about Mars. Mars is a really interesting one because of, I suppose we have so many spacecraft around it, and it's one that we know that we can land on and have a lander running around, or whether it be stationary or a rover. I don't know whether anybody's aware that from the early 2000s, every Mars spacecraft, whether it be NASA or ESA, I think even the Indians have one, have an Electra UHF system on board. Mm-hmm. It's a communications package. I think they moved to the new variation. So Odyssey was the first spacecraft to have it that was launched in 2001. But they went to the Electra Proximity Radio. So we're talking about relay spacecraft. And actually, I should say how the DSN's evolved when it comes to landing, especially around Mars. When I first started, so once a spacecraft hit the atmosphere, that was it. You'd have radio silence. So if you were having a lander going in, you'd have this period where you couldn't communicate. There was no progress reports that we had with like the MSL or the InSight. It just went radio dead. And the next thing we heard was either a nice signal from the lander on the planet, or we didn't hear it at all. We never knew what happened. And it was the relay spacecraft that we have around Mars that's allowed us now to see that whole descent. Actually MSL was probably the most thrilling experience I had. So I was in the room with a pile of VIPs, and so there was real excitement. So when they were doing the takeoffs, that was an excellent mission. And with InSight, you sent the Marcos with it as well as companion spacecraft, because it wasn't quite. We couldn't get the existing relay spacecraft to provide coverage. They were going to record it, but not in real time. Going forward, I think we've got Mars 2020, and so we do. So talk about long-term planning. So MAVEN, which is an atmospheric spacecraft going around Mars, it's got a really wide elliptical orbit. So you've got the spacecraft, so it comes out. And the reason is because it's sampling the atmosphere. So as it comes out in its orbit, it's slicing through the layers of the atmosphere. From February this year, it started to reduce its orbit just slightly. And this is all in preparation for the Mars 2020 mission. So for the Mars 2020 mission, we'll have MAVEN Odyssey and MRO all covering that descent as relay spacecraft. So I know the likes of Jupiter, I don't know, Saturn, I don't know, but CubeSats are opening a whole new world. The Marcos were the first ones that DSN supported. They're now talking of hundreds of CubeSats that we can support, where essentially we're just wide spectrum recording, looking up the sky. And so essentially the project will subscribe to that little chunk of spectrum. So these are the things in development. But I think the future of the DSN will be covering not only the flagship spacecraft or the Frontier or Discoveries, but I think we'll be supporting a lot more small CubeSats as well, which will have a very defined mission instead of this broad exploration. But yeah, it'll be interesting times over the next few years, I think.
And actually, Stoj, you asked, how does the Deep Space Network figure out which Mars spacecraft you're talking to, since they're all so close together? And I think you said you just pointed at Mars.
Yes, they are. So, actually, one of the critical things, so when it comes to project management, and so when a spacecraft gets proposed, it's allocated to channel, just like a CB radio. So, so you'll have channel 10 will be MRO, channel 20, so Odyssey, etc. Which is fine. So, and generally that channel is allocated for the life of that spacecraft, or proposed life, with a couple of extensions. With the likes of the rovers, so Odyssey, so the Opportunity, actually Opportunity was a bit of an issue, because that was supposed to be long dead. And it meant that, so as we were trying to listen for a beep from the little rovers, the bigger spacecraft who had been assigned channels close to it were interfering. And we're getting that a little bit now with MAVEN and MRO. And if you look around Mars, there's like a pecking order of muscle around Mars, depending on the spacecraft. The MRO is a huge spacecraft, and it can transmit large amounts of data down, which means that it has high data rates, means a lot of harmonics that go out. And poor little MAVEN, when it's going through its low gain antenna support, just essentially just giving help, can be swamped by that. So even now, there are issues with clashes, and they have been allocated discrete channels in the first place. But yeah, it will be an issue going forward, I think.
Wow. I had a question I wanted to ask you, Richard, about, you mentioned, you went to college in the UK, and then you got headhunted and moved over to Australia. Why did you choose to work on the DSN? Was there anything special that drew you to it besides the fact that it was NASA?
To be perfectly honest, I knew nothing about the DSN. I failed to ask what NASA was doing in Australia. But it sounded such a cool job. And 30 years ago, we just didn't have Google. So most of the information was provided by the station. And I can remember starting off at the station, and I said it was the Voyager era. I was recruited to support the Neptune encounter, and it was very different days then. A lot of it was manual, and actually the one big advantage is the level of automation that's come into the network. It allows us to track 4 occultating spacecraft around Mars. So where if you just had a controller coordinating the comms, they'd be twitching. So you have these spacecraft going into occultation, coming out of occultation, drive-ons, so half a round trip light time before it comes out. So as it comes out, we're hitting it with the transmitter, then we'll be twitching. So automation has made a huge difference as well. And I've seen that evolve over the 30 years. But as far as why I did it, if somebody walked into a lecture theatre and said, who wants to work for NASA in Australia? I don't know anybody who's technically minded who wouldn't.
Yep, fair enough.
Yeah.
What about the wildlife down there? There's a heap of birds and stuff, and a lot of roos down there. Like, do you run into any issues with the wildlife? Do you have to shoo them off the property? Is there anything special that goes on?
No, so actually, until quite recently, so we had just a standard farm fence around the complex. We've now gone to a higher fence. So quite often you'd be walking up for lunch and there'd be kangaroos standing next to you. So I think the fences, obviously there was a security aspect where somebody could just walk into the complex, so it wasn't particularly good. But it has kept the wildlife out from around the antennas. But we still have the issue when we're traveling to work. So the chance of hitting kangaroos, wallabies, wombats, foxes, emus, and deer, strangely enough.
There are deer
there's a wild deer population as well. They're an introduced species, obviously. So yes, the cars are frequently being cycled through the crash repair sort of place. So yes, it's an issue. And we're talking about wombats just before the show aired, and there's nothing worse than hitting a wombat. I mean, that can take out an oil sump. There was one poor wombat that we found on the road just at the bottom of a dip, and the animal has obviously been hit, and probably about 3 meters from the hit mark, the oil started. So obviously, as the car had hit it, so it cracked the oil sump, and we just watched all the oil slowly drain out of the car. We followed it for about a kilometer before it obviously came to a grinding halt. So yeah, there's a fair amount of destruction involved. But it's the same with Goldstone. We were talking about the burrows as well.
Yeah.
So they're everywhere in Goldstone.
Yeah.
And, so you certainly got to be careful for those.
Yeah.
Those and the tanks running through, because Goldstone's in an army base.
Yes. Yeah. Just for some funsies, the army base that when we went was on a heightened alert or whatever. I don't know. It's probably been like that for 20 years. And there were 10 of us in the group, and we all had to go in individually and literally spend 15 minutes getting cleared to allow us to walk from this side of the desk to this side where the door was at. So it literally took 2.5 hours for our group to go from one side of the building to the other side. And then we were allowed to walk back around and grab our cars and go in. So that was fun.
This is the Fort Irwin gate. Yeah.
Yes.
We have this, to be honest, even if you're employees, you have the same issue.
Oh yeah, I bet it is not easy to get in. Well, it's intentionally not easy to get in. So some of our questions that we have left. Rocket Simplicity. This is a good one. If relevant, would large satellite constellations such as Starlink and OneWeb eventually interfere with the DSN? Because I could tell you, astronomers, yeah, it's interfering, and they're pissed. So, what about DSN?
Look, so the DSN is lucky. So we do have international treaties, and our spectrum is protected. So vigorously. So we do have within Canberra our 4G communications. Has certain frequency bands blocked out, just in case it deals with us as well. But there's certainly a big risk, depending on what frequencies these constellations are using, to possible interference. We do see that now, mainly on the Sierra Band spacecraft. You'll look out, and then for a little bit of a period, you'll see interference coming through, and it can actually take out telemetry as well. And you just assume that you've got a spacecraft in low Earth orbit transiting across your beam. But we were really lucky when it comes to interference. I said with Mars, the biggest issue is around Mars. So with the number of spacecraft we have around there. But terrestrially, yeah, as I said, so we fight for our spectrum, and it's protected in each one of the around each one of the three complexes.
And John Benstead on YouTube is asking, how about communication relays at one of the Lagrange points? I think that might fall under the same idea, Look,
so it's probably feasible. But I suppose it's the size of spacecraft required. So we've got a number of spacecraft around Lagrange 1. And so the beauty of Lagrange points is they're really stable, and even if you don't have to be sitting there, you can be orbiting around it. So as we have with a number of spacecraft, but it's just the fact that the spacecraft you'd have to build with some sort of twin high gain antenna that's steerable. We can make it steerable to Earth, but then you have to make it steerable to the spacecraft you're talking to. Look, it's probably so conceivable, but I don't think it's as far as cost. I don't think it's cost effective.
Yeah, I was about to say it's definitely an answer that often gets what I get when I'm talking with my friends about space flight and, well, why don't you do this on the mission? And it's like, well, complexity and cost. So they go hand in hand.
Yeah, and the really sad thing is the complexity probably isn't, it's the cost.
Mm-hmm.
And you see it with the current missions, they're always fighting over funding. And I suppose there's always priorities. I mean, we see those same funding constraints within the DSN as well. We've had a flat budget for so long it's not funny. And what we've managed to do is we've managed to make efficiencies, and instead of just having them as savings, we're actually planning that back into infrastructure. So the new antennas that we have being built are a direct result of our cost savings. So we identified fairly early on that the DSN needs antenna. And so we're trying to create the software and systems to allow cost savings in one area, offsetting the cost of the infrastructure.
Gotcha. And our wrap-up one, Juggling Lessons from YouTube, is asking, would orbital antennas help? Do they provide anything that you can't do from the ground?
Well, you're talking about ground. Actually, we do have a space network already. The TDRS, or Tracking Data Relay Satellite System, when was that launched? In the 90s, late 90s?
I think it started in the 80s,
90s.
And they finally built it out in the early 90s.
Wow, yeah. Because essentially that took the shuttle supports off us. We suddenly had a network that could communicate to each other and to multiple missions at the same time. It's a multi-mission network, and downlink to White Sands. So there was just a single station for that, and it's brilliant for close Earth orbit stuff because it's like an umbrella. But it can only cover things below it. Mm-hmm. I'm not quite sure how big or how far out you'd have to go to encapsulate more, and whether you could actually have those spacecraft looking out. I'm not sure it would save costs. No, so one thing about the DSN, so we're actually very cheap to run. It's not an expensive network, considering the assets that we have. So again, it comes down to investment. If somebody's willing to invest a huge amount of money into space-based communications, I don't think we're going to see it.
All right. Well, Richard, thank you so much for coming on today. This was absolutely fascinating. This is like everything we wanted and more, and always leave them wanting more. And I think we definitely did that with you today. So we're going to have you come back on at some point. That's for sure.
I don't know. Actually, so I do have a Twitter account, just NASCOM1, and I try to answer any technical questions. So, because I love talking technical, so it's even better when somebody asks me a question.
Gotcha.
So if anybody wants to follow up after the fact, yeah, just post it on that. I'd be happy to answer it.
Yeah, well, there you go, everybody. NASACOM1 on Twitter. Hit him up. Let him get all your questions to Richard through there. So thank you again for coming on. Appreciate it. Thank you for bringing the 70 meter with you as well. We definitely appreciate that. Yeah, just
actually, if you may have noticed, we have changed orientation.
Oh yeah,
Oh,
wow. There you go.
For bizarre reason, Mars has moved.
I can see my
Yes,
house.
it has. Yes, and I thought I saw somebody walking down around near the bottom of it, but
Actually, that little antenna in the back, that's the original Apollo 11 antenna.
Oh,
That's
really?
where the first picture. Yeah, it was brought from Honeysuckle Creek to Canberra, Deep Space Communication Complex, so in the 80s. But yes, so we just had the celebrations for the 50th.
Oh,
excellent.
we're looking at history.
Yeah, that's so cool. Oh my gosh. All right.
Well, on that note,
Yeah, I
Yeah.
think on that we can't really
you
talk.
can't beat that.
It's hard to beat Apollo, so I think we'll wrap it. Thanks again, Richard. Have a great Sunday.
No worries.
Bye.
See you guys.